The Smoke Radio for the masses.
Headline edition, July 8, 1947. The Army Air Forces has announced that a flying disc has been found and is now in the possession of the Army.
If the game is rigged, change the game. Game changer.
I occasionally think how quickly our differences worldwide would vanish if we were facing an alien threat from outside this world.
This is Fade to Black with your host, Jimmy Church, on the Game Changer Radio Network.
All right, good evening, Fade to Black. How you doing? Today is Monday. You've been waiting for this. That's right. It's December 23rd, 2024. You've been waiting for it. Avi Loeb or Christmas? Yeah, you like how I did that, right? I'm your host, Jimmy Church. And now I want to, before I just get into a very, very, very long intro here and stuff, I want to make things kind of quick. It is Christmas week. Tomorrow is Christmas Eve. We have no show tomorrow. Of course, we have no show on Christmas Day. And then we are back on Thursday for a show with Rion. Rion's going to be here. And here's the deal. Rion, I'm going out to Sedona to hang out with Rion de Ruin and his team for their conference. And so Rise of the Guardians. So he's going to be on with this on Thursday. So tonight, Avi is with us. Tomorrow night, off air, except I've got a bunch of Christmas Eve things that I have to get done tomorrow, right? I'm seeing people and doing some things. If I get back and I have the energy, I just may jump on tomorrow night to do a quick Christmas Eve hangout with everybody. I think that will be a lot of fun. So just keep that on the back burner, and we'll see if we can make that happen. Of course, Wednesday no show. Thursday Rion is here. So really quick, I've got 4 major events coming up. I have the Conscious Life Expo at the LAX Hilton. That is February 7th through the 10th, 2025. Right after that, I just mentioned Rise of the Guardians, March 29th and 30th, 2025 in Sedona, Arizona. Then the Contact Modalities Expo in the Midwest, May 2nd, 3rd, and 4th, 2025 in Delavan, Wisconsin at Delavan Lake. And then I head back to Peru for the Inca Celebration of the Sun on the solstice. And this is June 17th through the 27th. And I just got back from Peru and then turning around in 2025, 2 more trips to Peru. So the links for everything with Brian Forster, it's so cool. The links for everything are below. I'm hosting all of the events. I'm speaking at the events. So just come and hang out with us. The links for everything are below. Now, we are in some crazy times. I just want to get straight to it. Live from Israel tonight, we have Avi Loeb with us. I've kind of framed this show around a few different subjects. The search for alien tech, which is something that he is centrific with and working on. What is out there? What is the status of the universe right now? I want to talk a little bit about dark matter and dark energy, the things that I'm very, very fascinated with. And everybody knows I love physics, and I try to incorporate all of that into not only this show, but into my world. So we're going to be doing all of that tonight and much more. I discussed with Avi before the show. We are going to go commercial free tonight. So that is our Christmas gift, our Hanukkah gift to all of you. We're going to be talking about, I hope, a little bit about Oumuamua, the Galileo Project, of course, the search for alien tech. Who are we? What is our place in the cosmos? We're going to do that. We've got mysterious drones flying over my house right now as I speak to you. Maybe we'll get into some of that as well. Of course, he is an astrophysicist. He's a cosmologist, the Frank B. Baird Jr. Professor of Science at Harvard University, and the longest serving chair of its Department of Astronomy. All of that and much more. By the way, I've got both of his books. Both are autographed. and Interstellar and Extraterrestrial. You can head over to Amazon and get your copy. The links for everything are below. I would like to welcome back to Fade to Black. I'm just going to say it. My good friend, Avi Loeb. Avi, man, happy holidays. How you doing?
Happy holidays. Greetings from the Holy Land. I was actually in Jerusalem over the weekend and visited the Armenian quarter there. And I wrote an essay about that because it reminded me how limited is our perspective, because there were so many atrocities represented by things I saw over there. You know, the Armenian genocide during the First World War, followed by the Jewish Holocaust during the Second World War. And, you know, it just strikes me that, we are not obviously the pinnacle of creation, and we are do not represent intelligence in the best way. And
we don't.
That will bring us to the subject.
Yeah. That's a great intro to the show, because technically we are the hillbillies of the universe, right? And to that end, let me ask you this: if ET, I'm saying if, okay, let's just go with if, because you know my position on this. ET is watching you and I right now on this show. But let's say if ET has visited this planet, that means they have technology that we haven't gotten to yet. Would you suppose that ET in their evolution would have gone through the same things that we are going through here, like Holocaust and bullets and racism and comedy, and good music, and maybe Van Halen too as well? But you know what I mean? Would they have evolved through the same things that we need to get through and work through?
Well, I believe there is a distribution. Just like in any class, you have students of different qualities. And if you ask me, we probably represent the middle of the road, so to speak. There must be a better student in our class. And how would you know? Well, if they manage to get to us before we manage to get to them, it means they are far more advanced. And, the sun formed in the last third of cosmic history. So we are late to the party. There were lots of stars like the sun that predated it by billions of years, and most of the stars are this way, actually. And therefore, there were probably things like us billions of years ago. We just need to open our mind. And why do we need to do that? Because, look how we behave when we just focus on this tiny rock that we were born on. We believe there is nothing else. We look down on other people, and we do all kinds of things to feel superior to other people. And, we invest $2.4 trillion in military budgets worldwide, a third of which is in the US. And if we just decided to allocate the same resources to finding our partners out there, we could send a probe towards every star in the Milky Way galaxy before the century ends. Hundreds of billions of them for the same amount of money that we spend on defense. It's just a question of what we care about. Now, I'm not naive. I don't think that people will one day sing the song of John Lennon, "Imagine all the people living in peace." I just don't think it will happen. I think we need shock therapy. And, that will come from a visit by a more intelligent neighbor. It will basically change our perspective. It will introduce some humility to the way we operate. And once we see that there are partners out there, perhaps we will feel more connected with each other, the way that Ronald Reagan, in the speech, President Reagan spoke in the words that you just aired. And that is my hope, that the Messiah will not arrive from this earth. It will arrive from another star.
How would we? Okay, let's stay right here for a second. I think it's an amazing accomplishment that technologically, we are now able to peer into the atmospheres of exoplanets. That's insane that we have gotten to that point in when 25 years ago we didn't even know if there were exoplanets out there, right? So that's pretty amazing. But if you're going to be on the lookout for alien tech, is it possible to see the lights of a city at night on an exoplanet? Because I think that would be a pretty indication of some action going on an exoplanet. Is it possible for us to do that? Or if not now, will we be able to do that in the near future?
Well, I actually asked this question in a paper that I wrote a few years ago. And together with an undergraduate student from Stanford University, we did the calculation, and we found that it really depends on the level of illumination. If you have city lights on the dark side, on the night side of an exoplanet, you would see an excess illumination of that side, which is supposed to be completely dark, depending on, of course, how much light they produce. If it's at the level that we are illuminating, the night side of Earth, it will be very difficult, even with the Webb telescope, even with the next generation of space telescopes. However, if they produce as much as 1% or more of the day side illumination, which is potentially possible if they just convert the energy that shines on their day side with an efficiency of 1% to illuminate the night side, then for the nearest planet near Proxima Centauri, we calculated that it may be possible to detect it with the Webb telescope. So, it really depends on what the aliens are doing and how close they are to us. And by the way, we tend to think that if they exist right now. I mean, my guess is that lots of exoplanets are full of graveyards of aliens that used to exist there billions of years ago. It's just that, either they inflicted wounds on themselves through nuclear war, biological war, their own geopolitics, which may have
cosmic debris. Could be anything.
Or there was something that impacted the planet, or the star evolved. The sun in 7.6 billion years will brighten up, become a red giant, engulf the Earth potentially, and eliminate any option for us staying on Earth. And if we don't go on an exodus in a spaceship, I call it Noah's spaceship. Noah in the biblical story tried to save life on Earth from the great flood by building this ship that he used. And this is a metaphor to what a civilization might do when facing the end of the life of its parent star. They will just go on an exodus, pay a lot of money to leave the planet. Not all of them will do it, but there will be some cries for help. There would be, and we didn't hear those because we were not around. We've been around, humans were around only over the past few million years. Modern technology that allows us to detect signals from others existed only for a century. A century is one part in 100 million of the age of the Milky Way galaxy. So we were just listening at the end of the history, and there could have been a lot of cries for help. So as a result, most of those civilizations may have left behind the planet, which is now a desert and burned up perhaps by the star, if not engulfed by the star, and then migrated to the center of the dying star. These things happen many times, and we just were not around to realize it. Finding those dead civilizations would be very challenging because you have to visit those planets, or, it's really difficult to tell remotely whether there was a civilization on a planet that was burned up by the star. But I think most of them went through that, most of them. And the only ones that we would find evidence for are either around today or they develop technologies to escape their planet, and we would find all of these probes near us eventually if they launched enough of them.
Do you think if the amount of advanced evolution is too extreme, do you think that ET would care about us or just be
No,
curious about us?
I don't think so. We tend to think that we are really the focus of attention. It started with
Right.
us being at the center of the universe. And obviously, it flatters our ego to think that way. It also helped the church in advocating that God cares about us because we are at the center. You know, my daughters, when they were young, they thought the same. They thought that they're at the center of the world, and that's because their experience was very limited to people at home. And indeed, we took good care of them, and they were at the center of our attention, the parents. But when I brought them to the kindergarten on the first day, they had a psychological shock, realizing that lots of kids like them. And, you know, I had a conversation with a group of members of Christianity Today at Harvard. They asked me to speak with them about extraterrestrials. That was a couple of months ago. And there was this question of whether it contradicts the religious belief. If there are other civilizations, you know, how can God think of us as special? And I try to explain that I have two daughters, and the love that I have for one does not take away from the love that I have for the other. So if God is really capable, God can attend to a very large number of civilizations like us throughout cosmic history. That, to me at least, it doesn't pose any issue, unless you think that God has a very limited attention span, and then you think perhaps God is not capable of dealing with multiple civilizations. I think that there is no issue.
Let me jump in on that. I love this. Okay, I didn't expect this to go in this direction, and I tend to leave religion and politics off of the show, but it is Christmas, by the way. And by the way, the baby Jesus is watching this show right now. I'm sure of that. Okay, so it is this. If we extend a little credit and boundary to the Christian belief system, if we do that, then God is everything. So there shouldn't even be a consideration from a Christian group about what would God. No, what are you saying? God is everything. You don't even question that. You don't have the right to question if God has consideration over aliens.
Well,
he created them.
Well, what I'm advocating is a sense of humility. You know, if you realize that you're a small piece of the universe, it shouldn't bother you that there are others out there. You know, when you have siblings, you should not be jealous of the siblings if the person that is in charge of you is all capable, you know. Now,
you understand we agree on this, right?
There is another aspect that I wanted to bring, and that is that you know, we don't know what happened before the Big Bang. It happened at a specific time, because if you know, we see the universe expanding. If we go back in time, there was a point in time where the density of matter and radiation was infinite, because things get diluted as the universe expands. And there was a time 13.8 billion years ago when everything started, the expansion. And the question is, what happened before then? Okay. And we don't know the answer, scientifically speaking, because at that time, Einstein's theory of gravity broke down. It's called the Big Bang singularity. But we know why the theory breaks down. It's because it doesn't incorporate quantum mechanics, which is very important at high densities and temperatures. And we don't have a theory of quantum gravity that unifies quantum mechanics and gravity. Einstein wanted to develop it, was not successful. Over the past 50 years, string theorists tried to do that. Again, they don't have a predictive theory. They didn't make any single prediction or explain any phenomena that we observe that was not explained before. But suppose we develop a theory of quantum gravity, or aliens developed it because they had much more than a century of science and technology, then they would have a recipe for how the universe started. They would know the ingredients of what was there before the Big Bang and how it ended up creating the Big Bang. Okay, so if you have a recipe for a cake, you can bake the cake, or at least you know how to make it. You know which ingredients to put together, in which order, how to apply heat and generate the cake that you want. So if you ask what is the one requirement, if you wanted to apply for the job of God, what would be the basic requirement? As far as I can tell, based on traditional religions, it would be the ability to create a universe. You need to do that at the very least, because that's where everything started. Now,
Can you imagine that conversation? Honey, have you seen our son Bobby? He's out creating universes tonight. He'll be back. He'll be back for dinner. And
So
okay, well, but really important point here though. 10 years ago, Avi, the question of the Big Bang or what is it possible, or could it, or did it, or what was before, that was heresy in the world of physics. That was a solid foundation, man. Nobody really went there. And now today, and why do you think that is? That suddenly these conversations can happen about what happened before, what was here before. Did the Big Bang even happen? Does the math make sense? Is there an alternative here to Big Bang theory?
yeah,
You understand, it's a pretty crazy time in the world of physics.
yeah, I mean, we know what we don't know in this context. We don't have a predictive theory of quantum gravity that can allow us to understand what was there before the Big Bang. And perhaps one day, perhaps another civilization has it. So what I'm saying is, if we discover better scientists on another planet that know the answer to what happened before the Big Bang, if I meet aliens, that would be the first question I ask them. Okay, because
What's that? Wait. What is the question? Just in a basic sense, what would you ask?
the question is, what happened before the Big Bang?
Oh, good one.
Because
Yeah, I
we
like that.
share the same universe, and if they
Yeah,
have an
yeah.
understanding of quantum gravity, they would know the answer. Now, that could be a way of bringing together science and religion, because if we find aliens that know the answer to this question, that know the recipe for making a baby universe, they would be a good approximation to what traditional religions called God, because they potentially can have quantum gravity engineers in white lab coats creating baby universes. Just think about it. If you know how to do it, maybe you can do it. The thing is,
I like that.
but by the way, it's not necessarily true. You may know how to do it, but you just don't have the oven that can make this cake. That is possible as well, that you need to reach very high energies that you cannot access with existing particle accelerators. You know, that is possible. But
It's really good. It's really good baking parchment paper. That's what you really need. Yeah, but okay. You know what my question would be? And yours is, yes, you almost changed my mind for me. But my question would be, how did you guys survive? That's
yeah,
all.
well, that obviously is helpful for us as well, because there is Darwinian evolution among civilizations, and you ask which civilization will survive, which one will last the longest. I think that is a sign of intelligence. The civilization that is most intelligent is the one that would survive for the longest. But you can think of it as tautology. I mean, I define intelligence in terms of the ability to survive despite all odds. And that means that you should not be self-centered. You should be looking out to the stars, out to the sky, more than you look down on the rock that you were born on. You just pay attention to what happens where most of the real estate is. Most of the real estate is not on this rock. And we find for territories and so forth on this rock. So now you ask me, suppose a very advanced civilization is out there. Will they pay attention to us? Will they really want to see what we are doing? I don't think so. I don't think we are that significant. We haven't yet risen to the level that would require attention from someone that is a much better student in our class.
Except,
because
no, that's what I just interrupted Avi Loeb on Christmas. Oh man, it's hot in here, Avi. Except though, just let me jump in. Except what we are doing is looking for alien life, alien technologies, and exoplanets. We want that question answered, and we're putting a decent amount, not as much as we should, but what's the new telescope in Chile? The big ass telescope that's getting ready to come on.
The Rubin Observatory, the Vera Rubin.
The very large. I just said big ass telescope.
Vera Rubin. Oh no, there will be also the extremely large telescope.
The extremely large telescope.
Yeah.
So we're putting resources into this, right?
Yeah.
Well, ET would be doing the exact same thing. They would have scanned the galaxy in the universe looking for other exoplanets. And when I remember when you and I were having dinner one night, and we were talking about the amount of planets in the Milky Way, and you and I were throwing numbers around 50 billion, a trillion, 100 billion, trying to have a conversation about this. And I would say that our beautiful blue gem kind of stands out, even with what we've detected already, right? We're looking for another beautiful blue planet. Well, ET scanning everything would go around and go, whoa, check. This one looks pretty cool, right? It's got all of the things. So now maybe we aren't the most intelligent, but the planet itself is worth stopping and taking a look at, isn't it?
Well, I actually wrote an essay a couple of weeks ago about what is the best real estate that we can imagine, in the universe. And I'm not sure, obviously when you are born at a home, you think that's amazing. The home is probably the best that one can have. But then once you start checking out the neighborhood, you might realize there are much better homes out there. And that's the way I think of it, that ours is just one out of, hundreds of billions within the Milky Way, and there are 1 trillion galaxies like it, all together in the observable volume of the universe. So there are 10 to the power 22 planets like Earth around stars like the sun within the entire volume, the observable volume of the universe. And there are many more beyond what we can see, beyond the cosmic horizon. We know that because we know that there is no cliff just outside of what we can see, because it would show itself through gravity. We would notice it in the cosmic microwave background. So we know that our universe continues for at least 4,000 times farther than we can see, with very similar conditions. So you have, 10 to the power 31, at least.
Man, that's a big number.
Yeah. Now, why would you think that
number.
our home deserves attention given that? I'm not sure at all. And even within our neighborhood, you might ask, is our home the most desirable? And I would argue not necessarily, because, the universe in the future, it's not only expanding, the expansion is accelerating. So that means we would lose all galaxies that are away from our local neighborhood, because they will eventually escape from us faster than light. They're speeding up away from us, and eventually they would reach the speed of light within 10 times the present age of the universe. We won't be able to see them. They will exit our cosmic horizon.
Yeah, that's lonely, isn't it? Is that
that will be really lonely. But then you can ask, okay, are we lucky? Well, the answer is we have the Milky Way galaxy. That will be the resources that we can use for survival in the long term. There are better residents of the cosmos, those that live in clusters of galaxies, that contain 1,000 times the resources that we have in the Milky Way, because there are 1,000 galaxies like the Milky Way in a cluster of galaxies. The nearest one is called the Virgo cluster. And it's 50 million light years away, but in principle, we can get there before it will escape from us. And those residents in clusters of galaxies are more lucky because they will have 1,000 times the resources that we have. So their Christmas tree includes much more. I don't think that we are privileged, both in terms of our intelligence or in terms of our real estate. I just think we are probably a typical place, a typical home on the street. And instead of being proud, let's explore that neighborhood. Let's figure out who else is out there, learn from their lessons. If they perished on their home planet for a variety of reasons, it's good for us to know that so that we can prevent a similar fate. If some of them became far more advanced than we are, we can get a quantum leap in our technological abilities by finding their gadgets. It will not be iPhone 18, it will be iPhone 100 that we might find, or a ChatGPT 200, or whatever it is. We tend to think that they would be a mirror image of ourselves. That's the way we imagine things. That's good when you go on a date with a partner that is a human, because you share the same DNA. The person that you meet on a date would have 2 eyes, 2 ears, a nose and so forth, because you share the same DNA. But meeting someone from another star is a completely different ballgame. They may not represent the same DNA that we have. They may not have, liquid water as the basis for life. It may be, I don't know, ammonia or something else. Who knows? My point is, we should be open-minded, not assume anything about our privileges. And it's very likely that there are residents of our cosmic street who are far luckier than we are in terms of their intelligence. By the way, I define AI in 2 ways: artificial intelligence and alien intelligence. Both of them are AI. The question is, which one will we learn from first? I mean, both may have, in the near future, we may encounter superhuman intelligence, in the form of AI within a decade or 2. It will be the first time that we play with an object or a gadget or an entity that is smarter than us. Just think about it. When we drive a car, the car is dumber than us. Every object that we created in the past and every tool was less intelligent than we are. So we would feel satisfied when we drive the car very fast, the way we like, in a street that we want to go to. We feel satisfaction because we control it. But for the first time in history, we will have artificial intelligence that may be smarter than us, let's say in a decade. That would be very frustrating to some people, because the AI will manipulate us rather than we manipulate it. We might think that it actually aligns with us, but it will have a second face where it actually is giving us the impression that we are using it, but in fact it will use us. And
well, isn't that what we do with other humans?
Yes,
right?
Exactly.
Yeah.
And by the way, that's why physicists are not the best equipped scientists to deal with AI in the form of artificial intelligence, because they are not used to dealing with intelligent beings. That's the work of psychologists, for example.
Yeah, they're nerds. They're geeks. They don't leave the house. Right?
But the second AI is alien intelligence. And if we encounter them and they have superhuman abilities, it will be another encounter where a sense of modesty will be in place. And the question is, which one will arrive first? Superhuman intelligence in the form of artificial intelligence or alien intelligence? And I think that, there is a race between the two. The question is, how many scientists are searching for alien intelligence? Because if we don't do that, obviously we will not find anything.
Well, you better hope that AI, whatever form it is, artificial or alien, has a little empathy programmed into it. Right? No, I'm being
Well,
serious. No, I'm being serious. Have you seen the TV show Black Mirror? You're probably
no,
too busy. Okay.
no.
Anyway, there's an episode. It deals with the near future with society and usually with technology and stuff like that. But anyway, it's a very cool show. But there's this one episode where these robot canines, not unlike Boston Dynamics, right? The same thing, right? But are there to patrol and they don't give a crap, right? They don't have empathy. You're not petting this dog and trying to make friends with it. It's there to kill you and it doesn't care. You can't reason with that. And that's the scary part about AI.
Well, that's scary, but I would say don't count on empathy because you're dealing in the case of AI, artificial intelligence. You're dealing with a machine made of silicon chips, not of flesh and blood, the way our brain. So even though we call it neural networks, it's not the same as the neural networks that is in our brain. Our brain, by the way, is using only 12 watts of electric power. 12 watts is nothing. It's like a tiny light bulb. Whereas these, large language models right now are using gigawatts of power. They want to build nuclear power plants to power the next generation. And so these are very different beasts. And they're trying to align them and think that they would cooperate with us the way that human brains do, I think is wishful thinking, because it's just like putting lipstick on a pig. You want to make the pig look better, but the pig would not actually be a human, even if you put lipstick on it. And so we have to be ready that qualities like empathy will not be there. Now, they may be, actually, they might be in the face that the machine shows us. The computer shows us some empathy, and we would think, oh yeah, it really cares about us.
Just to manipulate you, to manipulate you.
It will just be to manipulate. I mean, humans do that as well, of course.
Oh, we do. That's why we all understand what you're saying, because we practice this. And yeah, I just don't think coming face to face with an AI that's up to no good visiting this planet, that you're going to be able to reason with it and say, but I've got kids. I just don't think that's going to work, man. I don't. My mom.
We should not count on that. But the first, we need to do it first of all, we need to search and see what we find. Now, this we should do by, someone asked me, okay, how do you imagine aliens and what are you looking for? And I said, well, I don't need to imagine or to look for something specific. I just want to find something that is unfamiliar. So, for example, if you look at objects, the way that the unidentified anomalous phenomena are, that are reported to be objects maneuvering in ways that cannot be reproduced by our technologies. That's a very good definition, in the sense that you are looking for something that is not familiar, doesn't look like a drone, a balloon, an airplane, a satellite. You can look for those things that are not familiar, that because we know the things that are familiar, that there is a finite number of them. We can feed a machine learning algorithm with all of these things that we are aware exist in the sky, like these drones that were reported in New Jersey, and there must be many drones nowadays, and satellites and airplanes and so forth. And once the machine learning gets good in the task of identifying what is familiar, it could flag anything that looks not so familiar, that looks strange and weird, and these are anomalies. And I think we should focus on things that are not familiar and see what we find. That's one thing for UAP, the unidentified anomalous phenomena close to Earth. But in the same way, we can investigate life in the cosmos. Look, like, for example, the thing that I'm mostly curious about is whether the second object in the solar system that has liquids on the surface, there is only one other object aside from Earth. Earth has water on the surface, liquid water.
On the surface. So Titan,
exactly. It has methane and ethane. And if I had one wish in the solar system, I would like to go fishing on Titan, because the question is, are there any fish swimming in the lakes, the rivers, the
Octopus.
ocean?
They have octopi.
I will
I'm-
not eat them, by the way. It's a health risk to
yeah, right.
if they are made of methane and ethane. But I would like to know if life is possible with a different fluid other than what we have here, and that would be life as we don't know it. Of course, there could be also life as we know it, but it just strikes me as there are many more environments that could potentially have life as we don't know it. And
Well, you're an astrophysicist and a cosmologist. So let me and we've talked a lot over the years, but let me try to get some stuff out of you that I've never asked before. DNA, chemistry is chemistry. Particles are particles. That what's on the other side of the universe should be the same stuff that is over here. I'm assuming hydrogen and carbon and methane and anything, helium and oxygen are all the same as what we have over here. But if that is the case, then because particles can only combine so many ways, Avi. That's it. There isn't an infinite combination process. So wouldn't DNA be not only repeatable, but normal? Right? Just amino acids and those basic sugars combine in a certain way. And with the vastness of the universe, that stuff should be absolutely everywhere. So I don't think bipedal aliens are out of the questions. 2 eyes, 2 ears, stereo. I think it's a question of gravity, how tall you are, how fat you. But I would say that DNA seems like it would be universal, don't you?
Well, that's a very fundamental question, an important one. We do see amino acids in interstellar space, and we don't know the answer to your question. It's an excellent question that can be explored in the laboratory. We can play with chemistry and see if we create always the same form of life or sometimes different. And but one thing that is important to keep in mind is, that there is the molecules of life on Earth. They have a preferred what is called chirality. You can define 2 ways by which polarized light propagates through a solution of the molecules of life, either right-handed or left-handed. There are 2 ways to organize in 3 dimensions the molecules, and it turns out that the DNA and RNA and they have one chirality. They're right-handed on Earth, and it's not clear what broke the symmetry. But one thing is clear. In fact, a week ago there was an article warning not to develop life in the laboratory with the opposite chirality, because if you have a pathogen that is harmful, it can escape all the defenses of the human body if it has the opposite chirality, if it's left-handed instead of right-handed, because all of our biological systems, they can recognize only the same handedness, and they cannot deal with something that is of a different handedness, and therefore such a virus, for example, would be able to penetrate, and there will not be defense against it that is currently available to all forms of life on Earth. All of them have the same chirality. So here is one additional warning. If you go to Mars, the way that Elon Musk wants us to do, at some point within decades from now, it's customary to worry about the health hazards from energetic particles, cosmic rays, because Mars doesn't have an atmosphere, doesn't have magnetic field to protect us. It's also, people also talk about the extreme variations in temperatures on the surface of Mars. Between day and night, the temperature changes by hundreds of degrees. So you have to prepare for that in order to protect humans. But the last thing that was not discussed much at all, except I discussed it in an essay just a couple of weeks ago, is if we go to Mars and there are some microbes or viruses or things that survive, because Mars lost its liquid water in the middle of its lifespan, 2 billion years ago, and probably there was life because we see evidence for rivers and lakes that used to be there with liquid water. And if there is any form of life that survived and it had a different chirality, the opposite chirality to the life on Earth, if it has had the same DNA as you suggest, but opposite chirality, we should be careful. That could be.
It's the movie Andromeda Strain. Remember?
We should not touch it because it could be quite harmful to the human body. We don't know if there is still something left over. By the way, if I ever go to Mars,
yes.
Well, it's best to hide in a cave from the cosmic rays, from the temperature variations. So just like, in prehistory, humans started by living in caves to protect themselves from the weather. If we go to Mars, we will go back to caves in the future. And when entering a cave, the first thing I would like to check is whether there are any prehistoric paintings on the walls of the cave or any relics of technology of someone that visited Mars, let's say 1 billion years ago, some other civilization, and went into a cave, and there is some remnants of a spacecraft or something over there. That will be the first thing I want to check before settling there. We've never checked that.
The Avi was here, right? We'll see it carved on the side. Do you remember? And for some reason, this has just gotten lost in the news. But about 5 years ago, it was announced that they found fungus growing on the outside of the Russian capsule of the space station. Now,
yes.
Let's just stop and examine. You're saying, so I read, I'm reading through, I'm like, does this really say what I think it says? That a life form survived the vacuum of space and flourished, right? It got energy. It got its nourishment. It grew, Avi. And they wanted to bring it inside for testing.
Well, there are two things I would mention on that. One,
I've seen that movie, man. I've seen that movie.
No, that's quite possible that life adapts even to these extreme environments. We know of tardigrades that were sent to space, and they survived. They were able to reproduce after being brought back to Earth a couple of weeks later.
They survived on the moon, right? I think they did.
No, on the moon, yes, it turns out there was a spacecraft that Israel launched called Bereshit that carried them, but it crashed, and we don't know if they survived. But there was a successful mission that brought tardigrades to space, and they were able to survive in the vacuum and the ultraviolet radiation, the extreme conditions, dehydration that space brings, and they could reproduce when they were brought back to Earth. So life can survive, and in fact, Elon wants to go to Mars, bring humans there, but there may have been astronauts, tiny astronauts in the form of microbes that came inside rocks from Mars that arrived at Earth. It may even be possible that we are all Martians, that life on Earth started. Second, that in fact life on Mars was the first because Mars cooled earlier. Mars is a smaller planet and it had a larger surface for its mass, so it could cool earlier than the Earth and allow for life to exist. It had liquid water.
Had an atmosphere, had a core that was moving. They were magnetically protected. All of that stuff was going on. That's not happening now, of course. But
so there is this last universal common ancestor called Luca, and it was dated recently in a recent paper just a few months ago. It was dated to 4.2 billion years ago. I mean, the Earth formed 4.6 billion years ago, And 4.2 billion years ago, we have the first common ancestor of all forms of life on Earth. Okay, now that's pretty early. At the time, there were both Earth and Mars were bombarded with large rocks, one of which created the moon. But there are lots of craters on the moon as a result of impacts and on Mars and so forth. And so it's quite likely that rocks from Mars arrived on Earth. And if life started on Mars first, then the life on Earth represents early life on Mars. That's possible. Now, in order to make the trip, which can take 1 million years on a rock, those microbes had to survive, and they could survive at the interior of rocks. So this is called panspermia, the transfer of life between neighboring planets.
Well, we found, Avi, this isn't open to interpretation, not to you, I'm saying in general for everybody, that those questions have been answered. We have found those amino acids. We have found those basic sugars of RNA on meteorites that have crashed into Earth. And so if they're traveling in our little part of the neighborhood, they're traveling everywhere like this, and dropping off these basic sugars.
Another thing we found is a rock from Mars that was analyzed around the 1980, and it was found that the temperature in the interior of this rock did not go above 40 degrees Celsius, meaning if there was life in the middle of this rock, during the impact that released the rock from Mars, and during the impact of the rock on Earth, when it arrived to Earth, it was never heated in the interior to more than 40 degrees, meaning that life could have survived in it. So we have at least one Martian rock that was analyzed very carefully. And that conclusion was based on the magnetic properties of the rock. If it would have been heated more, the magnetic properties of the rock would have changed. And they could tell that those were the original magnetic properties of the rock, and they were not changed by heating in the process of lifting it off Mars and bringing it to Earth. Now, we also know of organisms that survive very acidic environments. These are extremophiles on Earth, and it just shows you that wherever there is life, there is hope. And that gives me hope also for humanity. Despite all the toxicity you find on social media, perhaps we would find a way to survive together. I think that in times of crisis, we might find a way to come together, maybe leave our planet if it's not habitable anymore, and continue somewhere else. And if we can imagine a future of this type, someone else might. Well,
we don't have a choice. It's not a question of if.
Oh no, we would perish.
We have to split. That's and now you mentioned 7 billion years. I think it's probably to the extreme 5 billion years. But
it's even earlier.
Right.
7.6 is when the sun will
blow.
No, it will become a red giant, expand to by a factor of 100. And engulf the Earth. It will become very different than it is now. But before that, within 1 billion years from now, which is 20% of the age of the Earth, within that time frame, the sun will brighten to a level that will boil off all the oceans on Earth
and the atmosphere.
Yeah,
this
so
would be at 1,000 degrees on the surface of this planet. It's kind of uncomfortable.
Yeah.
Right?
Yeah, and it's the ultimate global warming. It has nothing to do with what humans are doing. By the way, we tend to think that all the catastrophes that we inflict on Earth will really be terrible, but Earth went through much worse than that, than what we are doing. And I think Earth will survive. Actually, speaking about Earth as something that survives is maybe inappropriate, because it's not an organism, but But planets go through a lot of terrible things, and you can see what happened to Mars. It became a desert, even though it had rivers, lakes, oceans on it. So it's really about us. It's not so much about the planet. We need to find a way to live longer. And one solution to Fermi's paradox is that civilizations like ours just live for a few centuries once they reach the technological state that we are in, and then they create some catastrophe that prevents them from continuing to be around. And we just don't want to end that way. I think it would be far better if we find a way to leave the planet, to build a platform in space that could carry us. But for now, I just want to get inspiration from others that managed to do that. And that's why I established the Galileo Project, 3.5 years ago. And by the way, last month we had our first data paper. We looked at 500,000 objects in the sky. That was the commissioning data of the first observatory that we built. And you may say, okay, well, there were lots of observatories in the past that astronomers created. And why is this one special? It's special because we are looking at the entire sky all the time and monitoring it in the infrared, optical, radio, and audio. And there was never an observatory of this type. And we are using machine learning software to figure out if there is anything unfamiliar in the sky. So the commissioning data was analyzed in a paper that we posted publicly. By the way, we will share our data. We are not a government organization, and the government obviously classifies a lot of data because they worry about national security. Anything that is human-made, for me, is boring. And so just to give you an example, people reported about drones in New Jersey. If these are really drones and they are not behaving in ways that are unfamiliar, I don't care. I will let the government figure it out. I'm not a law enforcement entity that wishes to figure out what our adversarial nations are doing. That is not my goal. I don't care about what humans produce. I just want to see if there is anything else. So the Galileo Project is now collecting 100,000 objects per month with the one observatory we have.
That's a lot of objects.
Yeah.
And did anything that you can share with us? Was there one anomaly in the data where even Avi stepped back and went, okay, well, man, shit, that's interesting. Let's
not yet. How you would know if something like that happened? Because there will be a paper, an article just about this object. Whenever you see from the Galileo Project articles or papers that talk about statistics of objects, we looked at 1 million objects, we found a certain fraction of them to behave one way, a certain fraction to behave another way. That means that, it's not as exciting as a paper that says, here is one object that behaves in a very crazy way, okay? Because that would be the exciting result. And I keep asking, of course, members of my team, did you see anything like that? And so far, we don't have good enough data to indicate one such object, but we may have one such object. And by the way, even if 1 in 1 million is behaving in this way, that would be big news. The thing about ARRO, the All Domain Anomaly Resolution Office, is they make statements like, mission accomplished. 97% of the objects we looked or the reports from military personnel appear to have an explanation. 3% we don't know about. Well, that may be satisfactory for a government organization like ARRO. It's definitely not sufficient for a scientist like myself.
That's the 3% that you're interested in.
Exactly. And we know that there is a mixed bag. We know that there is a lot of crap that humans produced in the sky, a lot of it. So it cannot be the case that most objects are extraterrestrial. It must be a very rare situation. I mean, it would have been much easier to find those odd ones 100 years ago. You know, if I had a way of doing the Galileo project 100 years ago, it would have been amazing, because then you would not have the clutter of 6,000 Starlink satellites out there, things like that. And
last year, Avi, I saw two objects follow the same path that went from the north to the south, horizon to horizon, in about 1 second, and it was about 15 seconds apart. And the next day I called you and I gave you the time. You remember that? I gave you the time. Yes. I gave you the directions, and I was freaking out. I was out of my mind. In fact, I texted you that night and I said, okay, it's happening right now. And then I called you the next day and I said, somebody out there has to have seen this. There's no way that, right. Let me know. And you got back to me and you said, man, nobody's saying anything. I can't find any reports about this. Now, I find that interesting, that it's something that was undetectable or was too fast, but it doesn't change my experience.
Right. No. Yep. That your experience is exactly the reason we work around the clock trying to build additional observatories. So we have one in the Boston area. We are now about to put a second one in Pennsylvania next month. And by the summer of 2025, have a third one in Nevada. So altogether, we have funding for 3. Each of them costs between $0.5 to $1 million. But we will get 3 times the data. And we hope to equip each of them with multiple units that allow us to triangulate, to figure out distances. That's really critical, because when you observe an object in the sky from one vantage point, you can't tell how far it is. But when you observe it from 2 vantage points, just like having 2 eyes, you are able to figure out the distance. And once you know the distance, it's not just a matter of how far the object is, because you see it moving on the sky, okay? So the actual speed by which it's moving depends on distance. If you have a fly moving close to you, it would look as if it's moving very fast because it crosses a huge angle over a short time, but it's actually because it's close to you. And so knowing distance is really critical. And we in the Massachusetts Observatory, we will have that hopefully within a few weeks. We'll have multiple units that allow us to figure out distances, and then we will install the same thing in Pennsylvania and Nevada. So we will know the velocities of objects and also the accelerations. These would allow us to identify those that are really weird, like you are describing. And what you are describing is obviously motivating us. That's why we want to do this. The other thing I should say within the Galileo project is the ocean expedition that I went to in June 2023. And by the way, there will be a Netflix documentary showing what we went through, going to the ocean and picking up materials from the crash site of the first interstellar meteor that landed there a decade ago, on January 8th, 2014. And so we went to the crash site, and where the fireball was located by US government satellites. And we scanned that region by putting a sled with magnets on it at the bottom of the ocean, which is about a mile deep there. And we went back and forth 26 times and collected some materials, millimeter-sized droplets, a meteoritic material, and we analyzed them and published
nothing this big.
No, well, actually, that's what we want to do in the next expedition. And for that, right, we will employ a robot, a remotely operated vehicle with a video feed that would allow us to see in real time what we are picking up from the ocean floor. That will cost $6.5 million. We are seeking a donor, someone that will be able to support it, because we have a ship that we identified, that we agreed on, we reserved it, but I haven't found a donor as of yet. And I tried for 6 months now, and We tried to reach out to Elon Musk, didn't hear back. It's really crucial.
He's too busy running the country.
Politics, yeah.
Yeah,
But
yeah. Too busy running the
it's not
country.
a lot of money for some people, and we might lose the ship. I mean, we were planning to go in summer 2025, but if we don't, by the end of December, if we don't get funding, we will probably lose the ship. And my hope is that we will get funded and go again to look for bigger
pieces. You and I talked about this before. I will say this publicly right now. If you are out there, you've got 6.5 large that you can spare, contact me and I'll put you in touch with Avi. And, you know, let's do this. The expedition's got to be called the Avi Fade to Black. But can I before we
and by the way, you will be the first to have a scoop, even on the ocean. If we are there in real time, we can connect, and just the way I'm, you know, right now.
That would be so much fun.
Just before my morning jog, here or on the ship, you will get a report from me.
That would be the biggest news, you know, in the history of that. Can I ask you something? What drives you? Don't give me the political answer. I don't want to hear about when you were a kid or this. No. There's something else there, fundamentally, something non-trivial that drives you. Share that with me. What is it?
I'm seeking a higher intelligence in outer space because I don't find it here on Earth.
That's the best answer I've ever heard. That's why you are the chair of astronomy. And staying on, that's such a great answer. Dark energy, Avi, and I love it how you don't really give a crap about what you don't allow other people to influence you. You are influenced by data and the facts. That's you, right? That's what
and curiosity, which is the engine that drives me. You know, I'm curious.
As it should be.
And you know what I tell students is never pretend to be the adult in the room. I mean, it's really important to maintain your childhood curiosity. You know,
it's okay to be the kid, man. It's okay.
Yeah, exactly.
So let's talk about dark energy, because I don't have a PhD. I don't. But at least I have the ability to think and ponder. And so when I consider, and especially that science is a series of corrections, and right now science is really starting to correct itself, going back to Edwin Hubble and the constant, and Einstein thinking everything was static, and he even had to change his mind. And then what happened in 98? Well, it's expanding exponentially faster. And now it's exceeding the speed of light at the edges of things. Okay. All right. Okay. A lot of guys were wrong. A lot of women were wrong. Okay. I can accept all of that. But where does the energy come from?
Okay.
The dark energy moniker is a made up noun to fill in the blanks of the math that nobody has the answers to.
Oh no, okay. So let me
What? Now let me finish, because I know you want to answer. But it's getting faster. The energy is getting stronger when space is getting less dense on the parameter. It doesn't make any sense at all.
Let me make sense for you. I will make it sense out of it for you.
Are you saying you understand this?
Yeah.
Okay, all right. Give it to me, Avi.
It's not complicated. I'll explain you the context. So we are used to the fact that gravity is attractive, right? We are stuck on the surface of Earth because we are pulled towards Earth by gravity, okay? That's because Earth has a positive mass, okay? In electromagnetism, we know that we have charges with positive and negative values, meaning that you can be repelled from if you are charged, you can be repelled or attracted. depending on what the other charge is. If it's identical to yours, then if it has the same sign, then you are repelled. If it's opposite sign, it attracts. And so in the context of gravity, you could imagine negative mass as well, okay? Just like in electromagnetism. It's not in contradiction to Einstein's theory of gravity to imagine negative masses, okay? It's possible in principle. It's just that we have never seen them, okay? Now, what would be the property of a negative mass? That gravity will be repulsive instead of attractive. So if you were next to a planet that has, like the Earth, with negative mass, you will shoot out of this planet. I mean, you will be repelled. You would not need rockets to lift off from the escape from the surface of the planet. Just gravity will push them out, okay? Just imagine taking a planet with a negative mass, putting it next to Earth, okay? If it has the same mass, that planet will push the Earth away from it, whereas the Earth will pull that planet towards it.
But does the force last forever, or does it weaken?
Well, it's just like gravity. It lasts forever. Gravity lasts forever, as far as we know. So what you would end up with is the two planets, one pushing the other, and the other attracting the first, and they will keep accelerating indefinitely up to the speed of light at 1g. So that will bring the two planets very close to the speed of light. In fact, with time dilation, they can cross cosmological distances. They can go across the universe because they get so close to the speed of light. So you may ask, okay, where is the energy coming from? I just described to you a rocket.
Yes,
wait a second.
Yes.
I described the rocket without any fuel. There is no fuel.
Yes. Okay, but as you get further away, wouldn't the force weaken and not get stronger?
No, because the two planets will stay close to each other. The Earth will
But the
pull.
Galaxies are spreading apart.
No.
Space is expanding.
No, I haven't gotten to that. So first, I described to you a spacecraft which is made of two objects of opposite masses that is not using any fuel. It's accelerating. You may ask, how is that conserving energy? Well, it's because one of the masses is positive, the other is negative. So the kinetic energy, the energy associated with the motion of one, cancels exactly the motion of the. So when you have a plus energy and the other one has a minus that energy, the sum of the two is zero, but the system is accelerating indefinitely, and the energy is not energy conservation is not violated. Okay, I started with that just to explain to you that negative gravity or repulsive gravity is possible. Now, what happens if the vacuum has... First of all, let me define what I mean by the vacuum. We are used to matter, for example. So suppose you have a very good vacuum cleaner. You are cleaning up all the matter. You are leaving nothing behind. Okay, so what is that? That is the vacuum. The vacuum itself is not empty. In principle, it could have some energy per unit volume in it, and it will be uniform everywhere, the same value. Okay, if you allow for that, so that the vacuum does not have zero energy per unit volume, but has a uniform, a constant value of energy per unit volume, energy density, then the only place where this would make a difference is gravity, because everything else in quantum mechanics depends on energy differences. And if the vacuum is uniform, there is no difference relative to anything else. So it doesn't matter.
Doesn't the temperature change?
No, it's vacuum. There is no temperature. It's the vacuum.
In the expanding universe, in the expansion of space, the more that everything expands apart, everything is going to cool down.
Yeah. No, we didn't get there yet. I'm still in the second step now. So
I'm doing pretty good for a radio host guy, aren't I?
Oh, you're doing great.
Okay.
So then if the vacuum has an energy density, and energy is equal to mass in Einstein's theory, E equal mc squared. So it doesn't really matter. You can say energy density or you can say mass density. It doesn't matter. It matters for gravity, and it turns out that according to Einstein's equations, having some mass density or energy density to the vacuum introduces repulsive gravity, meaning if you put test particles, like they don't contribute much to the mass density of the universe. You just put test particles, spectators, like us. Those particles will be separated apart by the repulsive gravity of the vacuum. This is what dark energy is. Dark energy is just the existence of repulsive gravity as a result of the vacuum having some mass density to it. And that's a result of Einstein's theory. It's not just the mass density that counts in Einstein's equations. There is also the pressure. And the pressure of the vacuum is actually negative. And you have to add it when you consider the effect of the vacuum on gravity. But when you take everything into account, it produces repulsive gravity. So now you consider galaxies or matter in the universe, and imagine it's just secondary. It's not really important for the mass density. The mass density of the vacuum dominates. At that point, the matter will separate by the repulsive gravity, will get diluted, will get cooler, as you just mentioned. The temperature will go down. And you ask, where is the energy coming from? Well, it's the energy of the vacuum that is creating repulsive gravity. That's all. You are used to the notion of attractive gravity, and that's why it looks paradoxical to you. But if you had repulsive gravity, you can just push things apart at a faster and faster speed. Now, the speed continues to accelerate because the vacuum is everywhere. It's not localized. If you had an object that had negative mass, then, as you say, when you get far away from it, that influence, gravitational influence, will die out. But if it's everywhere, you have the vacuum everywhere with the same mass density, the same energy, it doesn't matter. Wherever you go, you still get this repulsive gravity that pulls you.
And I understand all of that because I see it happening, and I read and I absorb it. I get it. But this is where I start to get a little clouded. Then why, if it's that strong and that constant, right? We're talking about from the Big Bang to forever. Okay,
Yeah.
forever is a pretty long time, Avi, right?
Well, that's
Okay.
that's that's the simplest version, in which the vacuum has some fixed value. That's what you are describing. Yes.
But yet it's not strong enough to rip the Milky Way apart.
Oh, yeah. That's very easy to understand, because you're comparing the repulsive gravity, let's say, of the vacuum, which has a mass density that is the average mass density of the universe, to an object that, like the Milky Way, that has a much larger mass per unit volume, much larger mass density. So the object doesn't care less. It has an attractive gravity which overcomes the tiny repulsive gravity on cosmic scales. So for this vacuum to be important, everything else needs to be secondary. The mass density of everything else needs to be. That's why the universe was not accelerating early on. Early on, the density of matter was higher. Before the universe got diluted, the density of matter and radiation dominated relative to the vacuum. So the universe was actually decelerating, was not accelerating. Gravity was attractive, and the universe was slowing down its expansion until the point where matter was diluted enough to become less dense than the vacuum. Yep. And then it started accelerating. But the Milky Way is already bound. It doesn't care about the vacuum. So that's why the Milky Way is not affected by cosmic expansion. And the same is true for the solar system, and the same is true for us on Earth, because
our atoms are
exactly
the same thing.
Exactly.
Yeah. Okay. So, and that's the other thing, where we have, strong and weak forces. We have, one type of gravity that's holding our bodies together, and the forces that keep us together, all the way to what's keeping us glued to the Earth, what's keeping the moon in its position,
right,
what's keeping the Earth around the sun, what's keeping our star system consistent.
Right.
Outside of that, our sun is moving and our star system is moving, right?
Yeah,
And
but
outside of that,
what matters in all these circumstances, if it's gravity that you're thinking about, what matters is the mean density of the object. If the density of the object is bigger than the cosmic density of, then it doesn't care less about the vacuum, the accelerated expansion of the universe. And by the way, we all know that because, if you take a very dense object and pass near it an object that is less dense, the second object can get ripped apart by gravity. This is called, by the tides that are raised. This is called tidal disruption. And a planet like the Earth, by the way, if you were to pass it close to the most common star, a dwarf star that has 10% of the mass of the sun, turns out the most common star is 10% of the mass of the sun, 10% of the size of the sun. So altogether, it's 100 times denser than the sun. The most typical dwarf star is 100 times denser than the sun, and therefore it's much denser than rock. The sun has roughly the density of a rock. By chance, it's a complete coincidence. So if you were to take the Earth and bring it close to the sun, it will not get ripped apart. It will actually eventually get engulfed by the sun once it's inside the envelope of this. However, if you bring it close to a dwarf star, you can rip it apart. It will get spaghettified into a stream of rocks. And, that could be an origin for rocks in interstellar space. And I wrote a paper about
a rogue dwarf star, right? Wanders through our star system. That's a bad day.
Oh, no. I mean, if you happen to be on a planet that was born close to a dwarf star, that's the most common circumstance. Yeah, we don't know. I mean, Proxima Centauri has a planet in the habitable zone. Next to it, Proxima Centauri is a dwarf star, 12% of the mass of the sun. And there is a planet there, roughly the size of the Earth, at the right distance to maintain life or liquid water, the chemistry of life as we know it. We don't know if there is life on the planet next to Proxima Centauri, but if that planet was brought closer to Proxima Centauri, then it could have been ripped apart. That's what I'm saying. So gravity cares about the density of the object. And if you have an object that is much denser than the cosmic density, then you don't care less about the vacuum. Only when things get diluted, which is the case on very large scales in the universe. When you deal with millions of light years, over there, the density of matter is less than the density of the vacuum.
Yeah, and there was a report. I don't want to spend any time on this. I just want to say this really quick. There was a report that came out about 3-4 months ago that dark energy or energy doesn't necessarily need mass, which contradicts, to exist, which contradicts, of course, Einstein. But then I started to think about this. If that's the case, that answers a lot of questions. But I'm wondering if that kind of points in the direction of maybe dark energy is consciousness.
I'm not sure what.
Wait. I'm just throwing this out there, but there's a lot of unknowns, right? And things that we just don't have answers for. And I'm just wondering if that's one of the things that ET is going to bring to the table.
We don't know what dark energy is, what the nature of it. We don't know what the nature of dark matter is. That's 85% of the matter in the universe. It's of a substance we've never experienced. And it's possible that a more advanced scientific civilization knows these things and uses them. And so, you can see, let's say, a vehicle that is propelled by dark matter. You wouldn't see anything coming out of the exhaust. If it's repulsive gravity that is being used for propulsion, the way I described it, if you are able to bottle negative mass, you can put it in a bottle so that you use it for propulsion. That would be, you would need no fuel. That would be a means of propulsion we've never experienced, we've never imagined. So that's why I think it's important for us to seek more advanced civilizations, because we can learn about things we've never imagined before. And we should not argue that that we are searching for something specific, or that it's not worth checking because we are the pinnacle of creation, which is basically what the mainstream is doing right now. That they're saying it's an extraordinary claim to consider extraterrestrials or intelligence in outer space. I would say it's actually the other way around. It's extraordinary and extremely arrogant for us to think that we are unique and privileged and special.
You say arrogant, I say ignorant, but it's
Ignorant,
the same thing.
Yeah.
Yeah. What do you make of, and by the way, again, happy holidays, and thank you for taking the time tonight. And Avi and I agreed to go commercial free if we wrap things up a little bit early. It is 5 o'clock in the morning over there in Israel with Avi. So let's wrap with this. What are your thoughts on what is keeping the politics out of it, if we can? The conspiracy of politics is fine, Avi. What do you make of the hearings in Washington, D.C., and some of this testimony that has been going on in front of these committees and subcommittees, and the very focused and interesting questions from our elected officials? It seems that we have expert testimony saying that the government and the military is keeping secrets from us, and that contact has already happened, and we are backwards engineering craft, which is something that you've always been interested in. Right. And then the response and the questions from our elected officials seem to be very, very interesting. And I know that you're paying attention to this. What do you think is actually going on? Does the government have craft? Are they hiding those secrets from us? Is a secret like that even possible? What are you thinking?
Well, first, I'm very interested because it would save me time. Instead of me dedicating the next decade or two to search for something, if the government has it already, they should share it with all humans, because that has nothing to do with national security. It's information about our cosmic neighborhood, and it makes zero sense for them to keep it under wraps, because the best minds in the world can help them figure out what it means. As of now, if it's being hidden from view, it's a big waste, because first, we don't know about it, and second, and we misbehave because we don't know about it. And second, they cannot make progress because they don't have access to the best minds by hiding it. And so, of course, there were these testimonies, and I believe everyone who testified under oath. I truly believe that they were all sincere, and what they said is what they know. Now, the question is, can we actually, see the evidence? Can I access the materials, have a look at them, and or if there is craft, see it and study it? And the claim is it may be held by corporations, Lockheed Martin, others. I'm not sure where it is. I live next door to Skunk Works.
It's 1 mile. It's right there. Skunk Works is right there. So come out to the house. I'll take you down there. I'll show you.
I'll be well.
I'll show you.
But one thing we should keep in mind is the possible confusion with retrieval and reverse engineering programs for technologies produced by adversarial nations. That's definitely part of national defense, and I'm sure there are programs of this nature. And the fundamental question, as far as I'm concerned, is whether some officials try to hide what they learn about other nations, and therefore created this aura of it's just maybe it's extraterrestrial, just to confuse intelligence agencies from other countries and so forth, or to create within the public this confusion. So this is the one big question that I have, of whether there are programs for retrieval and reverse engineering or not. That's not a question at all. I'm sure they exist. The fundamental question is, did they recover anything that is not human made? And if so, where is it? Can we access it? And definitely we need more transparency. I don't think the government is equipped or competent enough, scientifically speaking, to figure out what these things are if they have them. And so I have a simple ask: share it with scientists so we can figure it out if you have it. However, I've never seen anything, so I don't know if it exists.
Do you when our best military pilots, this is where I start to scratch, because Avi, I've told you about things I have seen. I've showed you videos, right? Remember, we were sitting on my cell phone. I was going, Avi, check this out. All right, it's not like you haven't seen stuff like this. I am somebody that we're friends. You're going to look at it, and you did. You scratched your head and you said, wow, that right? Okay. All right, that's interesting. And so when our expert pilots, professional observers, right? Professional observers, this is what we pay them to be observers, right? See something that they can't explain, and they should know everything in the book, right? They should be able to identify anything in our skies.
Right.
When they see something that they can't explain, how much should we take that serious at face value?
You should keep in mind that there are always technologies that are not yet manifested in our daily life that are being developed by government, because they have a huge budget, of almost $1 trillion for defense, and they develop things that represent our future, technologically speaking, and we haven't seen it commercially. And so the pilots are trained on equipment that they are familiar with. It's possible that either adversarial nations or the US have access to technologies that are beyond those. And the fundamental question
part of it, but that should be part of it. Yes, of course. But then there's that 1%, right? There's that 2%. When something goes from 80,000 feet to sea level in a second, we would expect sonic stuff in our atmosphere. We would expect explosions, tsunami, things kinetically would be going off, and none of that happened. Well, if our adversaries have that technology, it's a bad day in Black Rock. And if we have it, and we're not sharing it with the kids in our schools, right? Farming, logistics, transportation of food, heating our homes, I don't think that's cool either.
Well, but Jimmy, the fundamental point is we need to nail it in terms of the evidence. And once we nail it, and by that I mean have scientific quality data with instruments that we fully understand, that are calibrated, which is pretty much what the Galileo Project is trying to do, but I welcome anyone else to do it as well. Mm-hmm. Once we nail it, or if we have access to a craft that was retrieved and it's clearly not human-made, so I'm not talking about photography, just actual materials, once we nail it so that nobody can doubt it, then the entire landscape will change. Of course, those people who are skeptics will start saying, oh, we said it all along, that it's quite possible. I actually spoke with one of them, Michael Shermer, who is a good friend of mine, and he is the editor of a magazine called Skeptic. And I asked him, if I find it and I show it to you, I want you to do one thing, and it is to change your magazine name from Skeptic to Believer. This is really what we need. We need tangible
What was
evidence.
his answer? Don't BS me, Avi. What was it? He's a nice guy, by the way. I'm not in any way bagging on Shermer. I would like to. But what was his answer? What did he say? Would he change the name to Believer? What does it take to move somebody like Michael Shermer off of the mark?
Well, that it's very simple. If we either have images of things or record motions of things that are evidently not human-made, but they are technological. For example, if we image an object like Oumuamua that was discovered in 2017, and it has bolts on its surface, and it's not a rock, then I don't think anyone within the scientific community would maintain any skepticism if the evidence is clear and beyond any reasonable doubt. That's what we need. And the thing is, we don't have it because most of them are not searching for the evidence. So it's a self-fulfilling prophecy. It's a way to maintain our ignorance. What we need to do is collect the evidence and show it. And any sane person that looks at the evidence, it's just like a jury. It will be beyond a reasonable doubt. And when it's beyond a reasonable doubt, we can convict the skeptics.
Now, Michael Shermer would probably be easier than Neil deGrasse Tyson.
Oh yeah.
Or is Neil starting to come around a little bit?
Well, okay. So the way I see it is science popularizers like Neil. There is also Brian Cox. They want to be popular. Okay.
Yes.
And they want to be respectable. They don't practice science, by the way. They broadcast to the public what scientists are doing. Okay. Now, in order to maintain their stature, they, as science popularizers, they follow popular view. They follow the wind. And, if the wind will change direction, if people will see the evidence and say, oh yeah, that looks credible, they will immediately switch because they want to be popular. Yeah. So they are not the authorities that need to be convinced. They are just like, movie critics. They are the people who express their opinion about what other people are doing. Okay. Movie critics are not producing movies. They're expressing their opinion about what other people work hard to accomplish. Okay. Scientists who are practitioners like myself, I write papers, I do the scientific research. That requires a lot of work. Those science popularizers are looking at the product of the scientists and describing them. And they would do everything they can to sound like the adults in the room, to basically express the folklore, the popular view at the moment. And if
to
there
keep
is
their follower count, they want to keep their follower count up.
Yeah, exactly. And
right?
they are not the people that we need to they don't count. These people do not count. They don't have the credibility of those who work in the trenches. It's just like a soccer game. What you care about is the players on the field. I don't care about the commentators are saying. This is completely irrelevant. So if you want to score a goal, you have to be on the field and you have to score the goal. Once you score the goal, the commentator will change their opinion. They will say, oh, now the player is great. Fine. I don't care about Neil deGrasse Tyson will change his view
colors,
and what he says. The minute we have that tangible evidence, he will immediately say, oh, many people before said that, I said that, it's obvious that things like that could exist, and now we see this. All these people that give us a hard time in actually searching for the evidence, they will claim credit for the ideas that the evidence reveals. And I don't think it's about us. I don't care who gets the credit. It's completely irrelevant. What I really care about is that we would have the correct view about our neighborhood, about, you want to know if you have neighbors when you live in a house. You can go around the house and be proud of yourself and say that you are extremely privileged. This is the most beautiful house. But for me, what counts is looking through the windows and searching for any objects that may have arrived to our backyard. Because
go down to the end of the drive. Go down to the end of the driveway. You know what I mean? Take a look around by the mailbox. You're right about it. Know who does that? You know who does that? Brian Greene. Brian Greene still works. Do you understand what I'm saying? He is still doing the math. He is still crunching the numbers. He's still working, and I think that his view is more open because he's seeing this shift in the numbers about what's going on. And I'm kind of digging where he's coming from right now.
Well, but if we find an object in our backyard, it will teach us about the neighbors. And, it's really simple. It's as simple as distinguishing a tennis ball from a rock that you find in the backyard, because it teaches you that the neighbor plays tennis. So,
Right.
if you ask me how difficult is it to convince a family member that you found a tennis ball rather than a rock, I think it's pretty easy. You just show them what you found. And once you have tangible evidence, then case closed. But when family members say it's not worth checking what is out there because I know the answer and it's an extraordinary claim that requires extraordinary evidence and I have other priorities than searching, then they will not find anything and they will maintain their belief system and they will stay ignorant. But what I'm trying to do is go out to the backyard and check. It's a simple procedure that any kid is aware of finding what is out there. And if you find tangible evidence, I think everything will change. All these skeptics will say that they thought about it first. I don't mind, as long as we have the proper view on our neighborhood. And it will. My motivation is that it will inspire us. That's where we started this program from. It will inspire us to do better. We can do better. Our role models should not be our politicians. Our role models should be more intelligent neighbors in near other stars.
Avi, happy holidays, my friend. Thank you so much. Be safe out there. I'll see you when you get back, and we'll move into 2025 and hopefully break some more bread. And just thank you for everything. Where can everybody go and reach out to the Galileo Project, help contribute, and move things along and stay up to date with what you're doing?
We established a few weeks ago the Galileo Project Foundation, which is a 501c foundation where donations are very much welcome. And I described them in one of my essays from a few weeks ago that has the words Galileo Project Foundation. You can find the link there. In general, my essays appear every few days on medium.com. So, and there is free subscription. You just search for Avi Loeb at medium.com and you will get updates about my research, the Galileo Project, everything else in the universe. And Merry Christmas to everyone. And I wish everyone a brilliant 2025. Let's hope that we will find evidence for our neighbors in 2025.
Keep doing what you're doing, Avi. It's good to see you, my friend. Oh, by the way, everything, for interest of transparency, and I love Avi's laugh, everything that Avi and I have done over the years has always been taped because Ozzy has to teach. He's got to go do things. And this is the first time, Avi, after all this time, that we've done something live. And you took the time to do this a couple of days before Christmas holiday season. Just thank you so much for doing this, man.
Well, thanks for having me. The challenge was that I had to wake up at 4 a.m. local time, and my wife woke me up at 2 a.m. because she heard the sirens from a missile coming from the Houthis. So I didn't get much sleep, but you can now tell that even if you wake me at the middle of the night, I will say the same things.
Yeah, so cool, man. Thank you so much, my friend. Happy holidays, and I'll see you on your return.
Thank you. Bye-bye.
Good night, Avi. Avi Loeb, everybody. That was a perfect night on Fade to Black. Avi just gave us an amazing holiday gift, okay? So everybody enjoy your holiday season. Tomorrow is Christmas Eve, and then, of course, Christmas Day. We're not supposed to have a show tomorrow. We don't have anything on the books. I've got a bunch of family stuff that I have to do tomorrow. If I get it done, I might come back to the studio in time just to do a quick live stream and say Merry Christmas, and we'll check on where Santa Claus is around the world. Okay? So until then, everybody, happy holidays, Merry Christmas. Thank you, Avi Loeb. I'm Jimmy Church. But for now, all I've got is Go Beckley Teppy. Fade to Black is produced by Hilton J. Palm, Renee Newman, and Michelle Freed. Special thanks to Bill, John, Dex, Jessica, Dennis, and Kevin. Webmaster is Drew the Geek. Music by Doug Aldrich. Intro, Space Boy. Fade to Black is produced by KJCR for the Game Changer Network. This broadcast is owned and copyrighted 2024 by Fade to Black and the Game Changer Network, Inc. It cannot be rebroadcast, downloaded, copied, or used anywhere in the known universe without written permission from Fade to Black or the Game Changer Network. I'm your host, Jimmy Church. Go back, Lee Tappy.